Okay, we're going to continue our discussion of naming with what we call polyatomics. And the word polyatomic, poly meaning more than one, and atomic obviously meaning atoms. So basically what a polyatomic is when you take a grouping of atoms and that whole grouping is going to have a charge. So for example, we could have sulfur with 4 oxygens and the grouping here would have an overall charge of 2 minus. When you look at this, you wouldn't think that this is, or you might think that this is sulfur tetroxide, but it's not. The whole grouping there is acting as if the grouping has a charge. So that's different than the compound SO4, which we call sulfur trioxide. The way you know the difference is if the charge is written there, you know it's the polyatomic. If that's just by itself, we would call that sulfur tetroxide. So let's just go through some of the polyatomics that you're required to know. I'm not going to list all of them, but I'm going to list the popular ones. We've got SO4 with a 2 minus charge, which we call sulfate. We've got SO3 with a 2 minus charge, which we call sulfite. We've got NO3 with a 1 minus charge. We call that nitrate. And we've got NO2 with a 1 minus charge. We call that nitrite. A couple of the other ones, we've got CO3 with a 2 minus charge. That's carbonate. We've got PO4 with that's a 4. Here, let me rewrite that. That's PO4 with a 3 minus charge. That's phosphate. We've got OH with a 1 minus charge. That's hydroxide. We've got CN with a 1 minus charge. That's cyanide. Maybe I could spell it right. Cyanide. We've got C2H3O2 with a 1 minus charge. We call that one acetate. And the last one that we have is the only one that has a positive charge. It's NH4 with a 1 plus charge, and that's called ammonium. Don't mix that up with NH3, which is ammonia. Ammonia is not a polyatomic. I just listed there to differentiate between NH4 and NH3. Ammonium, the polyatomic, ammonia, the compound. Alright, so let's do some practice with these polyatomics. The key to remember about writing formulas and naming compounds with polyatomics is you treat them the same way you would treat ionic compounds. In other words, we are looking for the positive charge and the negative charge, and then we're going to do our crisscross method. So for example, let's say we are going to write the formula for the compound aluminum sulfate. Write the element symbol for aluminum. You want to write the formula for sulfate, and since it ends in ATE, you know that it's going to be the polyatomic. So we've got sulfate with a 2 minus charge. We know that aluminum has a 3 plus charge. So again, we're going to treat it like an ionic compound. That number would go behind the sulfate polyatomic. That number would go behind the aluminum element or aluminum atom. So we would have Al2 SO4 3. If you're going to write a subscript behind the polyatomic, you've got to make sure that the polyatomic is in parentheses. On the other hand, if we had aluminum phosphate, we would have aluminum with a 3 plus charge, phosphate with a 3 minus charge. If you're going to crisscross those two, it would be a 3 and 3, but remember, we write ionics in lowest whole number ratios, so we would simply write AlPO4. In other words, you don't have to put the parentheses around the PO4. Now for now, if you put the parentheses there, that would be fine. In a couple of weeks, I would tell you need to stop using the parentheses. Okay, let's take a look at just a few more examples. Let's say we have ammonium hydroxide. So now we've got a compound with two polyatomics. We've got the positive ammonium and we've got a hydroxide polyatomic. So let's write the formulas. NH4 with a 1 plus charge, OH with a 1 minus charge. And again, we're going to have a 1-to-1 ratio, so we're simply going to write NH4OH. And the name of that compound would be ammonium hydroxide. So when you name compounds with polyatomics, you're simply naming the element and naming the polyatomic. So that would be aluminum sulfate. That would be aluminum phosphate. Okay, let's do a few more examples. Let's say we had magnesium. Let's use phosphate again. Magnesium phosphate. Okay, write the symbol, Mg, charge, phosphate, charge, crisscross, and we would get Mg3. We're going to put the PO4 in parentheses because we need that value to go behind the polyatomic, so we're going to put that polyatomic in parentheses. Okay, let's wrap this up and just do a little bit of review of the three types of naming that we've done so far. So far we have talked about ionic compounds, covalent compounds, and then what we'll call polyatomic ionics. Now remember, the first type of ionics we talked about were metals and nonmetals. So those are two elements, so we're going to call those binary ionics versus polyatomic ionics. So remember, with binary ionics, that was when we had a metal plus a nonmetal, and that's when we used charges, and then we crisscrossed the values to come up with our formula. And then we wrote those formulas in the lowest whole number ratio. Covalents are when we had a nonmetal plus a nonmetal, and that's where we use the prefixes mono, di, tri, etc. So for example, we had carbon monoxide versus carbon dioxide, or I suppose if it existed, you could have dicarbon trioxide. The reason we need those prefixes is because those two nonmetals can form multiple compounds, so you need to know what the compound is. As opposed to ionics, where the charges dictate what the formula is going to be, so there's no need to use prefixes, otherwise it would be redundant. And then the third type, which we just went over, were polyatomic ions. Typically it's a metal plus the polyatomic, and again, you crisscross based on charges, and the only time we have the polyatomic first is when we use ammonium with either a nonmetal or it's with a polyatomic. The next vodcast, or the next couple of vodcasts, will cover acids and bases, and then we'll talk about when we use Roman numerals with the transition metals. But that should take us up to where we have covered naming so far.